So glad to see you once again after a very tight schedule. So ready for a quick revision of the chapter sound? Let's quickly fly with the jet speed. Yes, here it is. Yes. Sound is a form of energy. Most important thing to remember, sound is a form of energy. It produces a sensation of hearing in our ears. Okay? Quite clear? Sound is produced by vibrating bodies. When a body vibrates, it produces sound. Wave or wave motion carries energy from one place to other. Energy, here it means sound, as sound is also a form of energy. Mechanical wave is a periodic disturbance which requires material medium, solid, liquid or gas for propagation. And sound is a mechanical wave. It requires medium for its propagation, be it solid, liquid or gas. And thus, we know that sound cannot be produced in vacuum. Sound wave is longitudinal in nature. I hope all of you know what is longitudinal and transverse waves. Yes? If not, we are going to clarify it in the further slides. Sound needs a material medium for its propagation, as already discussed. Sound cannot travel in vacuum. Again, a correlated point. Sound travels in the form of compressions and rarefactions. We are going to see what are compressions and rarefactions in the upcoming slides. Compression is the region for medium with high pressure or high density. That means the particles are very close to each other. High density, high pressure region is compression. And rarefaction means region of low pressure or low intensity is your rarefaction. So compression and rarefaction. Can you connect it? Now let's see. See the beautiful photograph there. Isn't it? Can you see? Compression. This is the region of compression and region of rarefaction. See, the particles are very far away from each other. Sound is a longitudinal wave. See, compressions and rarefactions in a longitudinal wave. Here we are discussing the longitudinal wave. See, the vibrating tuning fork produces sound. Yes, compression, rarefaction, then compression, rarefaction, and so on. This is a transverse wave and this is the longitudinal wave. Compression, rarefaction already discussed. And this is your transverse wave. Crest and trough. Can you see this? One cycle. This is one cycle. From one crest to another crest is your one cycle. Or from one trough to another trough is called one cycle. This is your amplitude and direction of traveling or propagation. Clear? See this very important slide again. So the maximum displacement of a vibrating body or a particle of the medium from its mean position, that is its original position, is called amplitude, that you have already seen in the previous slide. The SI unit of amplitude is meters. Look at it once again. See, the amplitude is marked. See? The red arrow? The amplitude is marked. This is the maximum displacement of a body or a particle from its mean position. Time taken by an oscillating body to complete one vibration is known as time period, denoted by T. Very simple. Number of oscillations made by a vibrating body in 1 second. This is very important. In 1 second is called frequency, that is denoted by F or also nu. So unit of frequency is this. Can you see the formula? Unit of frequency is hertz per second or hertz, and the formula relation between time and frequency. Can you see this? Time is equals to inverse of frequency, or frequency is inverse of time. Very important formula for very simple numericals. Now the next slide. The pitch or shrillness is a characteristic of sound that depends on frequency received by human ear. That is, pitch depends on the frequency. High pitch sound means high frequency. Low pitch sound is low frequency. Loudness of a sound is a characteristic of sound that depends on the amplitude. The higher the amplitude, the more loud the sound is. Okay? It is the subjective quantity and depends on the sensitivity of the human ear. For someone, a sound may be very high, whereas for the other person, the sound may be feeble. Timbre or quality is the characteristic of a sound that enables us to distinguish between two sounds of the same loudness and same pitch. If the loudness and the pitch of the sound is same, you can still distinguish the sound by its quality. Like, for example, I'll give you an example. You can easily distinguish between the sound of a guitar and that of a piano. Can you? Be it of the same loudness, be it of the same pitch, of the same frequency, but still you can distinguish. Why? Because of quality or timbre of the sound. Intensity of the sound is defined as the sound energy transfer per unit time per unit area. That is perpendicular to the direction of sound. Very, very important definition for your exams. Intensity of a sound is defined as energy transfer in 1 unit time, in 1 unit area, that is perpendicular to the direction of sound. Remember this, perpendicular. Intensity of the sound is objective physical quantity and can be measured. Intensity can be measured. Yes, the SI unit is joule per meter. See the relation between frequency, speed and wavelength of the sound. Mu is equals to V lambda. Now let's see what is echo. Now you have experienced echo many times whenever you scream through a high cliff. Your name. Right, you must have felt the echo coming. Why? Because it is the repetition of sound due to the reflection of the original sound by a large and hard obstacle. Your sound waves just hit the obstacle, that is the hard rocks or the hill, and then they reverberate, they come back. That is the echo. Multiple reflection of sound that follow closely behind the original sound. The sound appears to be prolonged. Ever face that in a cinema hall? So we were discussing about echo is the repetition of sound to the reflection of original sound by a large and hard obstacle. When it goes to multiple reflection, that is known as reverberation. Many of you, nowadays even the movie halls have soundproof material in their seats and curtains. That is why reverberation does not happen. They are basically made so as to prevent reverberation, as it causes sound clashes in the movie and just spoils the whole mood. Reverberation time is the time interval for which the sound persists after the production of the original sound. Jitne time tak sound will persist, that is the reverberation time. ये देखिए, what a beautiful diagram there. Reverberation, this is the sound. Echo, that is one time repetition. Reverberated sound, multiple echoes. When they follow each other so closely, the original sound, they are reverberated. This may happen in a concert hall or maybe in a movie hall. Yes, you see this picture. The audible frequency is 20 Hz to 20,000 Hz or 20 kilohertz. Very, very, very frequent question in your exams. May be asked in the fill in the blanks or maybe in the form of MCQs. Okay, maybe in the form of one word answer. So very, very important. Mark a 3-star. Infrasonic waves, waves of frequency less than 20,000. Ultrasonic, more than 20,000. Sorry, less than 20 Hz and more than 20,000 Hz. See, infra means less, come, right? So less than 20 Hz, the lower limit, and ultra, more, so that is more than 20,000 Hz. Human ear cannot hear infrasonic and ultrasonic waves, sound waves, but the animals and birds can hear these waves. Do you know, whenever there's an earthquake, dogs, birds, they're very aware of it. They are very sensitive to the infrasonic sounds produced. We cannot hear those sounds made by the tectonic plates, moving tectonic plates, but the birds and dogs can hear those sounds. And since you see, they are very, very sensitive. Human ear is a hearing device. It consists of 3 parts, very important: external, middle, and internal ear. So we are going to see the parts of external, middle, and internal ears. Hence, now I think approximately completed everything. Just you see, it is human ear, not ears. So by mistake, I have written human ears. It is human ear. That is your hearing device. Okay. Now next you see a very, very beautiful picture of human ear. See, I have zoomed in. First of all, just see outer ear, middle ear, and inner ear. See, outer, middle, and inner ear. Here it is. This is the ear lobe. You can see auricle. And just a second. Let me move this a bit. And yes, now clearly seen. Ear ossicles. These are the ear ossicles. The 3 bones: stapes, incus, and malleus. So we basically say them as malleus, incus, and stapes. Stapes is the smallest bone in the ear. Smallest bone of the whole human body. That also may be a question in your exams. Temporal bone, can you see this? This is the vestibular nerve, cochlear nerve, and this is cochlea. Again, if I slide down, yes, eardrum is there. Yes, eardrum, tympanic cavity. So this is a very, very beautiful picture. Now I hope the parts, the anatomy of human ear is quite clear to you, and thus the whole chapter. So here we come to the end of today's lecture. I hope you enjoyed it. Don't forget to like, share, and subscribe to my channel. And before going, let's have a closing quote, a very beautiful closing quote. Okay? See, here the quote comes. If you are not willing to learn, no one can help you. But if you are determined to learn, children, no one can stop you. So always be determined to learn and never stop learning. That's why I say bye-bye, keep studying, and don't forget to like, share, and subscribe for regular updates. Bye-bye, children.